Sets of real numbers. We're going to take a look at, are all numbers related, and we're going to concentrate on number sets. And then we're going to look at why or why not, so that we can tell the difference between them. In this class, we're going to concentrate on these number sets: whole numbers, integers, rational numbers, and irrational numbers. Now, when we're done, you should be able to tell which is which. Right now, we're going to focus on how can you tell them apart. So let's take each of these number sets separately and walk our way through them. First, let's talk about whole numbers. Whole numbers are the counting numbers: 1, 2, 3, 4, and 5. These are all those types of numbers, including 0. Remember the word whole. It is not a part of something. It's a whole number. So you'll notice that there are absolutely no fractions in the whole numbers. So that's what we want to think about when we think about whole numbers. Our second set we're going to look at are these things called integers. Now, integers, they're going to be the positive numbers and the negative whole numbers. So we noticed whole numbers before were all positive and 0. Now we're going to take the negative whole numbers. In other words, the opposite of the positive numbers. And then here's a couple examples for us to look at as well. So the question I have is, how are integers and whole numbers related? Well, we can kind of see that in our description up above here about integers, is that we can see that integers include the opposites of whole numbers. So we want to kind of keep that in mind. Now, since all whole numbers are integers, because integers include both positive and negative whole numbers, let's think about this question. Are all integers whole numbers? Does it work the other way around as well? Well, no, it does not. Because integers include, remember, the negative numbers. And negative numbers are not whole numbers. So even though all whole numbers are integers, not all integers are whole numbers. Now let's talk about rational numbers. Rational numbers are numbers that can be written as a fraction, and I'm showing you that as a over b. And then that would include decimals that terminate or repeat. Now let's remember that terminating decimals are decimals that end. When we talk about decimals that end, we're talking about something like this, 0.35. It ends, it terminates. When we talk about a repeating decimal, we're talking about a decimal that keeps going and going and going and on with the same number. That's something that we can also put a bar over it. If we can put a bar over it to show the repeat, then it's a repeating decimal. Even if there may be a pattern going on, if it's not a repeating pattern, then it's not a rational number. It must repeat in order to be a rational number. Now we're going to take a look here at some terminating decimals and show that there are different ways to write numbers. For example, this first one is 4 and 375 thousandths. The second one here is 2.5 or 2 and 5 tenths. And this one here is 3/9. So when we write these as fractions, this is kind of what we're writing. But we know that all of these can be reduced. So when we reduce them, we're showing here. Now the reason I'm showing you this is to show that we can have 3 representations of the exact same number. All 3 of these numbers, the ones that I'm circling, all represent the same number. So there are different ways to show a number. We have to kind of keep that in mind, because sometimes something will look to us that, oh my God, no, that's not a rational number, or you might forget that a repeating decimal is not a rational number. But you can see a repeating decimal can be changed into a fraction. That fraction can be turned simplified. So, and that's our first definition. If it can be written as a fraction, then it's a rational number. Now, all integers and whole numbers are rational numbers because you can put them into a ratio or a fraction by putting them underneath it. So if I had the number 24, the whole number 24, which is also an integer, put it over 1. Negative 8 is an integer, put it over 1. 567 and 0 are both whole numbers and integers, put them over 1. So because of that, therefore they are also rational numbers. So again, here's another question. Is a rational number a whole number? Well, that's kind of a tricky question. We want to ask, maybe, are all rational numbers whole numbers? No, they're not. And again, we know why. Because a rational number could be 3/4. And 3/4, that is not a whole number. That's 3/4 of a whole number. It's part of a number. So since it's a part of a number, it's not a whole number, but it's a rational number because it's a fraction. So even though all whole numbers and integers are rational numbers, not all rational numbers are whole numbers or integers. Okay, so let's talk about irrational numbers. Irrational numbers are numbers that cannot be made into a simple fraction. And when we talk about not being made into a simple fraction, we're taking a look at numbers that do this, that they have decimals that keeps going and going, and also they do not repeat. That is probably the most important part. They do not repeat. So when we're looking at this, here's pi, for example, 3.141592. It's going on and on and on, and it's never repeating. Okay? Here we have a number 4 and a decimal point, and here's 23233. We know that the next part is 2333, but there is no place I can put a bar over this to show a repeat, because even though the same numbers are being used, the pattern keeps changing, and because it's not repeating, it's considered irrational. Now, this one here on the end, the square root of 2, this is considered irrational because it is not a perfect square. Remind yourself about what a perfect square is. A perfect square is something you can take the square root of. For example, the square root of 4 equals 2. This square root here gives us a perfect whole number. If we can get a perfect whole number as the answer, then that's a perfect square. We cannot find a number that you would multiply by itself and give us 2. That's not a perfect square. So try to keep that in mind. And if you think about it, we did in the class a little Cheez-It experiment where we took numbers of Cheez-Its and put them together. We can't make a square from 2 Cheez-Its, but I can make a square from 4 Cheez-Its. So because of that, that's where that square comes into play. Now, the same thing goes with square root of 3, because I could not make a full square out of square root of 3. That is not a perfect square. So ones that are not a perfect square, if we take our calculator out, we would find that we would need to notice that this number goes on and on and on and on. And let me see if I can get our calculator up here for us so that I can show it to you. Let's get these over here. So our calculator, there it is. Here, let's take the square root of 2. You can see this number goes on and on and on and on. The same is true for the square root of 3. On and on and on, and it does not repeat. So we know that anything that is not a perfect square is automatically going to be an irrational number. Now, when we're looking at this, are irrational numbers related to anything? No, they are not. They're all by themselves because they cannot be made into fractions. So you'll notice if in this little diagram here, we have irrational numbers by itself and rational numbers. So that's to say that all numbers that we are dealing with, and the numbers that we are dealing with, are all in what we call the real number system. So all the numbers that we are dealing with in the real number system are either going to be irrational numbers or rational numbers. They're going to be one or the other. After we determine if they're one or the other, if they're an irrational number, they can't be anything else. That's it. They're done. If we determine they're a rational number, we need to really look at that number and say, hey, is that number also an integer? Is it also a whole number? It could be more than one number set. So we want to kind of keep in mind if that's possible. So we're going to practice a little bit with different types of numbers. Here we're going to look at this number here first. This is 0. We have the number 0. What kind of number is that? Well, we know that that's a whole number. It's an integer. And it's rational because I can turn that into a fraction. This number here, 2.454554555, repeating, we can see that, not repeating, but going on forever, there is no repeat. So because there is no repeat, that's an irrational number. And an irrational number has no other number set. I'm going to bounce back and forth between a couple slides here. The number -4. Now because it's negative, we know it's not a whole number. It's not a counting number that we learned. And because there's no fraction out here, we know, or decimal, we know that it has to be an integer. And because I can turn this into a fraction by putting a 1 underneath it, it's a rational number as well. Here I have the number 2 45/100ths. And because it's a terminating decimal, that means that it is a rational number. Because of this little piece out here, it cannot be anything else. Let's go back here and take a look at the next number here, the number 47. The number 47 is a counting number. Since it's a counting number, it is considered to be a whole number, which would also be an integer, and it would be a rational number. The square root of 6. The square root of 6 is not a perfect square. Since it is not a perfect square, it would be considered to be an irrational number. Negative the square root of 100. Well, we know that the square root of 100 reduces down to 10 times the negative 1. So really, this is negative 10. Since this is negative 10, it's just another representation. Remember, we were showing earlier that there's different ways to show numbers. So another representation of negative 10. Well, negative 10 is a negative number, so it's an integer, not a whole number, because whole numbers are counting numbers and we don't count negative numbers. So it's an integer and we can turn that into a fraction, so it's rational. Negative 0.6 repeating. So what that would look like is with a little bar on top of it like that. Now if it does that, that means that we can turn this into a fraction. And since I can turn it into a fraction, this is a rational number. And being a rational number, that's pretty much the only number it can be, because it is a fraction. It is not considered a whole number. Here I have the number 24 divided by 8. And again, we know that this number is another representation for a different number. 24 divided by 8 is also 3. So let's evaluate the number 3. This is a counting number, so this number is a whole number. It is also an integer. Therefore, it is also a rational number. Oops, get rid of that. Here we have the number pi. Now we just saw a moment ago, if you remember, we showed on our little diagram here, pi. Here's pi going on and on and on. Well, if it's going on and on and on, it's considered to be an irrational number. Negative 12. Well, negative 12 is an integer because it's negative, not a counting number. And it's also a rational number because I can put a 1 underneath it, and it would be considered a fraction then, therefore a rational number. 34.5. Because it's halves out here, that means it is a rational number, and it can't be anything else because it's not whole or an opposite. Let's go back here. 56 over 1, or 56 divided by 1. Well, 56 divided by 1, that's just another way to write 56. And again, 56 is a counting number, so this is considered a whole number. It's an integer, and it's a rational number. Negative 3.422, 422. Well, we can see this is repeating. This 422 is repeating. Well, since this 422 is repeating, that means that this is a rational number. Because it's got extra, it's not anything else. Here we go. Negative 81 divided by 9. Again, this is another representation for a different number, because negative 81 divided by 9 is negative 9. Negative 9 is an integer, and it's also a rational number. 3/4. This is a fraction. Because it's a fraction, it is considered to be a rational number. It is a part of a number, so that is all it can be. Let's do a few more. 279. 279 is considered a counting number, believe it or not, even though it's a very high number, but you could count up to that number without a problem. Therefore, it's considered a whole number. We can take its opposite, so it's an integer, and I can turn it into a fraction, so it's a rational number. Negative square root of 10. Well, if we concern ourselves with just the square root of 10, the square root of 10 is not a perfect square, just like the square root of 6 was earlier. This is not a perfect square. Whether it's negative or not doesn't matter. So this would be considered irrational. Over here, our last two that we're going to look at, I have negative square root of 25. Well, that's just another way for us to write the number negative 5. Well, negative 5 is a integer, and it's also a rational number because I can turn it into a fraction. And the last one we're going to look at, negative 7.5, because of this partial out here, we know it is not a whole number, and it is not an integer, and the only thing it can be is a rational number. So hopefully you're able to understand a little bit more about number sets and how to tell the difference between a whole number, an integer, a rational, and an irrational number.